Let's look at the code for breadth first search in Python. The way I plan to code is something super simple. So I'll use the dictionary type of Python's data type to form a graph. The good thing about dictionary is that the dictionary has an index and some information against the index. It can be a string, an integer, a set of mixed values, etc. So for our purpose, directing the node to its children in a way that the dictionary referencing is done is super simple and deployable. So I make a graph which is in Python a dictionary type because I'm giving an index and I am giving a list of nodes as a value to the index. So this means that when I refer to A, it it will give me the values of B, C. Also, to show you that this is a dictionary type, I can type keyword and put the name of this variable, and this variable has a dictionary type. So moving on, I want A to have two branches, B and C. For B, I want something more expansive, so I'll a couple of branches. Mm. You can also see that when you're at B, this is your frontier, right? Let's even write it. Frontier for once you've visited A, once A is visited, B and C is the frontier. Um, so let F be the leaf node. We don't put anything beyond it. So F is the leaf node, which means F will be empty, right? Also, we don't want to make it very deep, so make D also empty. So we have D, which should be actually over here. A, B, C, D. Uh, we should take to F. Mm-hmm. E should take me to F, and F is a leaf node. Then we have L and M to declare as an index. L should cycle back to A. This is A and M. And let's say that the M index is also a leaf node. So far, I just kept forgetting putting the commas to separate all indexes. So far, so good. Now, what else do we need? Once we have visited a certain node, we need to keep check so that, let's say, at point L, A is not revisited. To avoid these cyclic movements in the graph traversing, we need to have a check on what nodes have been already visited. List of nodes already visited. We also need to form a queue. So we are doing breadth first search, and it is a first in, first out queue development. Okay. So with these two lists declared, we create our first function, which is the definition. Um, we want to give it graph, which is the whole structure of our graph. We want to give it the node to start from, and let's say the goal node. If we don't give the goal node, then it will not have a stopping condition and it will traverse all the way to the end. Mm, so let's just wait and see what else do we need. For for this logic, we need to have a graph, and further we need to have a node from the graph and a goal node, and we have to append to the visited list all visited nodes. To start with, the first node that will be visited will be the starting node. So what we do is that we say, because we're starting from node A, the first node that is visited is node, and we have a list called visited. We append to it the node, which is the value of the first node that we're starting from. Next, we need to see what is on the queue for us. So right now, the queue also has the same node to start with. Uh, but if you look at the way this is structured, A is visited and A is in the queue. Where is A taking us? It is taking us to these elements. These elements are themselves the indexes to other frontiers or to elements of the list, and and then DELM are also index values over here, taking us further and further into the graph. So what we do is we say Q is not empty, while Q is not empty, if we have not reached the goal state. Because if we reach the goal state will be in the visited list. If it is not in the visited list, it means we haven't yet reached it. We will print s, and it will not print a new line. Right. So with this settled, um, now we start traversing the graph. For neighbor in graph S. So just remove this. Same condition checked, for the same reason that we don't want to get stuck in cycles. So if the neighbor has not been visited and this is a fresh branch being visited, we will first of all now make sure that we have appended it into visited list to avoid cycles. And the next thing we'll do is that we'll queue dot append. So next time what is explode is the index of neighbor. Okay. Let's see if this is correct. Okay. Now I'll just call this definition BFS and graph. I'm just giving the name graph for the graph, starting with node A, and let's say we want to go all the way to M. Okay, so I made one mistake over here. I forgot to declare what is the ns variable, which is the first variable that we peek into the queue and get out. So over here, the first variable of s will be b, because from this list we're popping b out, and when we pop b out, we declare s to be visited, but then we explore further what is b referring to, which is this frontier. When we reach b, our first s will be d, and then it goes in the loop. So first it will pop d out and explore what is d, which is how the frontier is explored. This is the logic to explore the frontier. Okay, goal state. So let me just put a space here to quickly make it A through M. We're reaching too quickly. So I'll just say let the goal be